Our solar system is a truly extraordinary place, filled with planets, moons, comets, and countless wonders. Yet, despite all we've discovered, there's still so much we don't know about the boundaries that define our home in the cosmos. What protects us from the harsh environment of interstellar space? What stands between us and the powerful cosmic radiation that fills the galaxy? For decades, scientists have theorized that our solar system is encased in a massive, invisible bubble created by the sun itself, a phenomenon known as the heliosphere. This bubble isn't just a cosmic curiosity. It's a critical shield that has protected life on Earth for billions of years. It acts as our solar system's invisible guardian, deflecting dangerous cosmic rays and interstellar particles that could otherwise threaten our planet. But how does this bubble work? What is it made of? And what have scientists uncovered about its structure and significance? Recent discoveries by space probes like NASA's Voyager spacecraft and cutting-edge missions, such as the Interstellar Boundary Explorer (IBEX), have shed new light on the heliosphere, revealing that it's far more complex and dynamic than we ever imagined. Today, we're diving deep into the mysteries of the heliosphere, a protective barrier shaped by the sun's solar wind. We'll explore how it formed, its crucial role in shielding our solar system, and what lies beyond its boundaries in the vast expanse of interstellar space. Get ready to uncover one of the most fascinating and critical discoveries about the forces that keep our solar system and life itself safe. Imagine a bubble, but not one you can see or touch. Instead, this bubble is made of charged particles and magnetic fields, stretching billions of miles across space. It's the heliosphere, a vast, teardrop-shaped cocoon that encapsulates our entire solar system. At its core is the sun, constantly releasing a flow of charged particles known as the solar wind. These particles race outward at supersonic speeds, creating a sphere of influence that pushes back against the interstellar medium, the gas, dust, and radiation that fill the space between stars. Where the solar wind slows down and collides with the interstellar medium, the boundary of the heliosphere is formed. But the heliosphere is not a rigid structure. It breathes, expands, and contracts in response to the sun's activity. During periods of intense solar activity, such as solar flares or coronal mass ejections, the heliosphere swells, pushing its boundary further into interstellar space. During quieter periods, it shrinks, drawing that boundary closer to the sun. Its shape is also intriguing. Unlike a perfect sphere, the heliosphere has a rounded front, shaped like a shield, and a long, trailing tail that stretches out as the solar system moves through the galaxy. This unique structure has led scientists to liken it to a comet or a windsock, constantly changing as it interacts with the galactic environment around it. For much of human history, the heliosphere was an invisible phenomenon. Its existence was theorized but never directly observed. Everything changed with the advent of space exploration, particularly with the historic missions of Voyager 1 and Voyager 2. Launched in the late 1970s, these twin spacecraft were designed to study the outer planets of our solar system. But after completing their primary missions, they continued on an unprecedented journey outward, becoming humanity's first explorers of interstellar space. In 2012, Voyager 1 reached a monumental milestone. It crossed the heliopause, the outer edge of the heliosphere, and entered interstellar space. Suddenly, the spacecraft's instruments detected a dramatic drop in solar wind particles and a sharp increase in cosmic rays. This was our first direct confirmation of the heliosphere's boundary. Voyager 2 followed in 2018, providing additional data and insights. The information these spacecraft sent back revealed the heliosphere's dynamic nature and confirmed its role as a protective barrier. But the Voyagers weren't alone in this mission. Other probes, such as NASA's IBEX and ESA's Solar Orbiter, have been mapping the heliosphere from within, using advanced technology to visualize its shape and structure. The heliosphere is more than just a scientific curiosity. It's an essential part of why life exists in our solar system. Without it, we would be exposed to the full force of cosmic rays, high-energy particles originating from exploding stars and other violent events in the galaxy. These cosmic rays can have devastating effects. They can damage DNA, increase cancer risks, and harm living organisms. They can also interfere with electronics, disrupting satellites and spacecraft. The heliosphere acts as a protective shield, deflecting a significant portion of these harmful particles and ensuring that Earth remains a habitable oasis. But its importance goes beyond protection. The heliosphere helps us understand how our solar system interacts with the rest of the galaxy. As the Sun moves through the Milky Way, it carries the heliosphere with it, creating a buffer zone that defines our solar system's cosmic environment. This interaction influences everything from the behavior of comets to the long-term stability of our planet's climate. As incredible as the heliosphere is, it's just the beginning of a much larger story. Beyond its boundaries lies the interstellar medium, a vast, uncharted frontier filled with particles, radiation, and magnetic fields. This is the realm that Voyager 1 and Voyager 2 are now exploring, sending back data that's transforming our understanding of the galaxy. Even farther out lies the Oort cloud, a hypothesized region of icy bodies that marks the true edge of the solar system. This distant shell, stretching up to a light year from the Sun, may be the source of long-period comets that occasionally visit the inner solar system. The heliosphere also raises profound questions. Do other star systems have similar protective bubbles? Could the heliospheres of distant stars play a role in making their planets habitable? And how does our heliosphere's interaction with the galaxy shape the future of our solar system? These are questions that scientists are only beginning to answer, but the possibilities are thrilling. The discovery of the heliosphere and its role in shaping and protecting our solar system is a testament to humanity's ingenuity and curiosity. It's a reminder that even in the vast emptiness of space, unseen forces are at work, influencing everything from the formation of planets to the evolution of life. As we continue to study the heliosphere and explore the space beyond it, we're not just learning about our solar system's boundaries, we're uncovering the secrets of the galaxy itself. These discoveries have profound implications for our understanding of the universe and our place within it. So, what lies beyond the heliosphere? What will we uncover as we venture deeper into interstellar space? The answers could redefine what we know about the cosmos and our role in it. One thing is certain: the journey is just beginning. Let us know your thoughts in the comments below. Don't forget to like, share, and subscribe for more explorations into the wonders of the universe. Together, we're unlocking the mysteries of space, one discovery at a time.